Hello friends, welcome to ictbird.com where we learn A-level ICT together. Today we are going to discuss the Advanced Level ICT 2020 Networking Essay question. Let's get started. If you do not have the past papers, head over to ictbird.com and download the past paper there. You can access this site by typing ictbird.com and click on the paper 2 download. So this is Advanced Level 2020 Past Paper 2, question number 6. Consider the following scenario. The PQR company has 3 departments, namely finance, marketing, and human resource. At present, all the activities of the PQR company are conducted manually. The company decides to computerize all their activities by establishing an IT unit with a computer lab for staff training. Resources will be allocated for each department and the IT unit as follows. So here they were conducting things in manually and now they want to computerize their company, and they already have 3 departments that are finance, HR, human resource, and marketing, and they want to add a unit for the IT department, which is the IT unit. So they have given a chart here, and the resources for each of the department or the unit is mentioned here. So the finance department, uh, they need 28 computers, and there's 1 network printer and one software server, that is accounting information system. So altogether we can see like 28 plus 1 plus another server. So there are 30 resources that are required for finance. Similarly, for HR, we have 40 plus a network printer and a HRIS server. So human resource information system. So this is a software server that is required. So 40 plus 1 again, that's 42. And here we have the IT unit, which has 50 computers and 1 printer. So this is not a network printer, as we can see. And we have a software server, which is learning management system. So altogether we can say like 50 plus 1 again 52. For the marketing department, we have 35 computers that are required, and we have 1 printer and marketing information system. So that's a software server. So again 35 plus 1, there we need 37 resources for this. So we'll just fill that up so that it will be easier for us. So we need 30 here, and for HR we need 42. For IT unit we need 52. For marketing we require 35 plus 1 plus, so that is 37, right? So we have the summarized information of what we require in terms of the resources for each of the department. The company proposes the following: a local area network LAN for each department and the IT unit in order to share specific software and resources. So company proposes LAN for each of these departments. So we need to prepare a local area network for each of these department. So let's see, the second point is LANs in each department to be interconnected via IT unit. So we have the IT unit here, and all of the other departments, all of the 3 departments will be connected to the IT unit. So so in a logical sense, it would be something like this. You have the IT unit here, right? So you have the IT unit here. So you have the finance, we have HR, and we have the marketing unit, right? So all of these units, so each of this is a separate local area network by itself, and this needs to be connected to the IT unit. All right, so that's the logical arrangement that we can see. All right. So the third point is all computers to be given efficient internet connectivity with the help of a DNS, domain name system, and proxy servers. So, okay, so we need to enable internet connectivity, and there should be a DNS server and a proxy server. Okay, so the fourth point is an internet service provider to supply the internet connectivity to the IT unit. So IT unit is where the internet connectivity will be given, right? And it seems like from there onwards, uh, all of these three departments, which are the finance, HR, and marketing, they will be getting the internet connectivity through IT unit, right? The entire network to be protected through a firewall. So there will be a firewall also involved. So here we see there are a few things here. Um, one is a DNS, and there's a proxy server involved and a firewall involved. All right. So let's go to the first question. Which network topology is the most suitable to satisfy all the above mentioned requirements? So the question asks about what topology will suit our requirement here. So basically, as you can see, um, there's a central thing like the IT unit, and the other um, the departments are connecting to it. It's sort of star topology right there, and each of these is a LAN, local area network, um, and probably it will have a switch, and then all the computers or the networking nodes will be connected to that. So there also what we would see is a star topology there. So um, the answer would be star topology. Give one reason to justify your answer. All right, so we need to give one reason. So there are many reasons why we would use star topology. Uh, it's basically how we can manage things, easy management. The maintenance of it will be easy, and it will be also be reliable, in the sense if one cable or device fails, then all the others will still continue to work, because for example here, if this one fails, so HR and marketing department will still continue to work, right? So the reliability factor is also there. So you can write down any reason there. um, and let's move on to the section B. The network administrator has received an IP address 192.168.14.0/24. So here we can see it is, this notation is called the CIDR notation, classless interdomain routing notation. And what this /24 tells is, for this IP address, the network bits are 24, and the rest of the 8 bits out of the total 32 bits is for host, right? So we have network in 24 bits and host 8 bits as the IP address block for the company. The IP addresses for the nodes are to be allocated after making 4 subnets from this address block for each department or unit. So IP addresses for the nodes are to be allocated after making 4 subnets. So here a network, an IP address block is given, and we need to create 4 subnets for each of these sections, like the finance, HR, IT unit, and marketing. And so the following incomplete table shows the subnetting. Write down the missing IP addresses for each department or unit using the following table format. Assume that subnetting is done under the consideration of future expansion of each department/unit. All right, so here we can say the list of departments, for the finance, they have given the values already. So here is the network ID, and here's the broadcast ID and subnet mask and the usable IP address range. So what we would need to find out is the rest of the entries here. So how we would go about that is, let's see. All right, so the key point here is we need to make 4 subnets, right? And we are given an IP address here. So I'll just write down the IP address. We have 24 bits for the network, so this is network bits, and we have 8 bits for the hosts, right? Host bits. So we have 24 network bits and 8 host bits. We need to create 4 subnets. So we need to create 4 subnets for these 4 departments. So in order to do that, we'll need to find out how many bits do we require from these host bits, right? So these are host bits. How many bits that we need to borrow from the host bits to create 4 subnets, right? So the formula is how many subnetworks that we require, that is 4, and how many bits that we would require is 2 to the power n bits, right? So that's network bit. So we need to find out how many network bits we require. So the 4 is basically 2 to the power 2, right? So we need these 2 bits, first 2 bits, to represent the 4 networks. So the network ID combination would be 0 0 0 1 1 0 and 1 1, right? And rest of these bits will be for the hosts. 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 6, right? So in this case, this is equivalent to 192.168.14.0, because you will be filling out all zeros here, and the broadcast address, so this is the network address, and the broadcast address would be these 2 zeros plus all the others should be 1, right? So 1 1 1 1 1 1. In that case you will get, so basically we are finding out the last octet here, so that would be 192.168.14. All ones here means that is 63, right? And this one is 0 1, so we'll be finding out the network address. So for that, with this 0 1, you have to put all the rest of the bits as 0 0 0 0 0 0. So that is equivalent to 64, right? You can do the math here, and for this one it would be 0 1 and all ones here, so that is 127, right? So I would write 192.168.14.64, 192.168.14.127, right? In this case, the network address would be 192.168.14. The first bit will be 1 and the rest of the bits will be 0, so it is 128, and the broadcast address would be 10, and all others should be 1, so that is 192.168.14.191. All right, and for this one, uh, the network address would be 11 and all zeros, so that is 192.168.14.11 means the first bit is representative of 128, and the second one is representative of 64. So 128 plus 64 is 192, and it ends at all ones here. So all these 8 bits made it to 1 means it is 255, right? 192.168.14.255. So basically we have derived how many bits that we require for the networks. So that was 2 bits, and we wrote down the combinations here 0001, 10, and 11, and we found out the network address, and we found out the broadcast addresses for each of these ranges, right? So this is pretty easy. And any of these network block, you could give it to any of the department here, because you see, from a host perspective, we had on the host side we already had 8 bits here, 1 2 3 4 5 6 7 8 bits here, right? And we took this for the subnet, these two for the subnet, and rest of the 6 bits for the host. And number of hosts for each of this network is 2 to the power, and how many host bits? That is 6 minus 2. So host per each subnet is 2 to the power 6 minus 2, that is um, 64 minus 2, which is 62, right? So each of the subnet will have 62 usable IP addresses, right? So that's what it means. And if it includes the network address plus the broadcast address, this number would be 64. Okay, so this is excluding network address and the broadcast address. All right, so let's quickly move on to the table and fill it out. 93.192.168.14.254, right? So there you go, that's your table right there, right? Okay, let's look at question section C, showing clearly the connection topology and the devices. Draw the logical arrangement for the company network that the network administrator can implement to fulfill the company's requirements, right? So the company's requirements, we know, for finance, 28 computers and a network printer and AIS. Um, so HR has this configuration, IT has this, and the marketing, right? So it involves a proxy server, a DNS server, and a firewall, right? So we would start um, with the internet connectivity here. So internet, so normally we would give a cloud there, and from there onwards we'll have the router, right? And after that we'll have the firewall. We have the firewall there. So from the firewall we'll get a connection to um, the IT department. So that's where the internet connectivity comes up. So we have this IT department switch. So we have a switch here where the computers and the printers will be connected, right? So this is the IT department switch. So if we take a look at the configuration for IT department, it has 50 computers, one printer. It's not a network printer, so we will have to connect the printer to the computer, not the switch directly. And we have an LMS there. All right. So, and also for the IT unit, what we have here for the network ID is it's a 14.128, right? So it has 50 computers. So this is computer 1 and this is computer 2, and let's say this is computer 50, right? And one of these computers can also have the printer, right? And one of these is what is the system called? That is LMS, right? So this guy is LMS, right? And because this is this is the network that has the internet connectivity, there you will have to have the DNS server as well as the proxy server. Okay, so altogether we have 50 computers plus the printer 51, and DNS and proxy server as well, and the LMS, right? So altogether we have some number of computers here, server including servers. So that's your so this is basically 192.168.14.128 network, right? So giving IP addresses, you will be giving like 192.168.14.129. Start with there. So this would be 130 maybe, right? So you can give likewise, and from this IT department we will be deriving the other departments as well. So there are 3 other departments. So one is the HR. So let's say this is SR switch, this is marketing switch. So these are all separate LANs by themselves, and we have finance switch, right? So depending on the number of computers and the network printer and the server that is required, so finance is so I'll just take this to the bottom, and that will make our life easier. Alright, so this is what we require for the finance. For the finance we would require 30 computers. So here is computer 1, this is computer 2, and here computer 30, and there could be a separate a printer as well here. Printer, this is the network printer, right? And then for the finance there was a system, right? So you can have that system here. Finance system is called AIS, HRIS, MKIS. Okay, so this is AIS. Marketing has an HRIS. Sorry, HR has an HRIS, and marketing has MKIS, right? Let's have a look at what else we have. HR has 42 computers. HR has 42 computers. So this is comp 1, this is comp 2, and let's say this is comp 3. This is, let's say this is 40th, and one for the printer. So let's say this is the printer, right? And one for the server, right? So that's how that 48 comes up. So finance also you go up to 28, and there's a printer and then the AIS. So that's what this is. And for the marketing you need 37 computers. So this is comp 1. This is comp. So that's 35. And you have the system MKIS system here and the printer, right? So each of this system needs to be connected to the IT switch, right? So each of these systems, HR, marketing, and finance need to be connected to the IT department. So this is your network diagram basically, right? And one thing is, if you want that to make this explicit, you can group these networks, right? So that's a separate LAN, that is a separate LAN, and this is a separate LAN, right? So if you look at this, finance is 14.0, HR is 64, HR is 192.168.14.64. Finance department was 192.168.14.0, and marketing is 192.168.14.192. Okay? So that's the network address of this each of these local area network, right? So this is your logical network diagram basically. So start with the internet, and after the internet you should have the router, and then firewall is uh, protecting the whole network, and the network starts with the IT department switch, which has the internet connectivity. So that's why you have the proxy server, the DNS there. And then from the IT department, you have the connections to HR department, marketing department, and finance departments, right? So this is how, and the one other important bit was, so there was a normal printer here. So here, this is a normal printer, so that normal printer needs to get connected to a computer. So this printer is connected to a computer. Okay, I hope that makes sense. And all right, so let's look at the last question here. So network administrator decides to dynamically manage the IP addresses of the entire network. So this assignment of these IP addresses to these networks, so he decides to manage it dynamically. Write down the mechanism that needs to be implemented to achieve this. So one way you can do that is go manually and assign these IP addresses to each of these local area networks. So that's one way of doing it. The smart way of doing it is introducing a DHCP server here for the main LAN, local area network, and then from there assign the IP addresses to each of these LAN, right? So that's how um, you can achieve that. So the answer would be introduce a DHCP server. Um, that is the answer. Okay, I hope that covered everything about this question, and hopefully we will be discussing more of the past papers in future. And until then, good luck. We'll see you in another video.